This problem, we are given an eclipse and a point 1, 1. Outside of that, here I have a straight line L passing through 1, 1 and intersect with eclipse with P and Q points, right? Assuming the straight line does not go through A is 0, -1. So we want to prove the slope of the straight line AP and the slope AQ add up to 2. Alright, so when we look at this problem, we need to figure out how to calculate the slope of straight line, right? If we know 2 points, the slope by definition is going to be the difference of y divided by difference of x. In this case, A is 0, -1, that is fixed. P and Q really depends on how L in the slope is, right? So the formula for that, for example, AP is going to be y minus -1, which is y plus 1, divided by x minus 0. So that's the formula for the slope of AP. However, in this problem, the things would be easier if we do coordinate translation. So we're going to move x-axis down to the A point so that it's easier to calculate certain things. So here we go. The coordinate translation is in this green line here is new coordinate. We call it x prime, y prime. You'll notice that we just shift the x-axis down, right, to the point A. Now A becomes the origin now, right? A becomes 0, 0. So what is the relationship with coordinate translation? Okay, so what are changed? With that, all the coordinates are changed, right? And the equation will change also. However, since it is simply a translation of the coordinate, the shape itself and the dimension of the shape are not changed. So what is invariant here with this transformation? We say that orientation of the shape, the dimension of the shape, and the slope of line, those remain the same value. However, even though individual points, the coordinates is going to change. All right. So I have a table here, right? For example, in the old coordinate with xy, in the new coordinate with, say, x prime, y prime, this is how they're related. The second row here is the eclipse equation. In the new coordinate is going to be this, and here's the point A. In the new coordinates becomes the origin at 0, 0. Now point 1, 1 becomes 1, 2 in the new coordinate. Now the slope formula here is simpler. In the original coordinate is y plus 1 over x. Here is simply y prime x prime because A is the origin now. All right. So that's some of the changes with new coordinate. But again, the actual value of the slope and the shape of the eclipse, the dimension, everything remains the same. All right, that's important to know. All right, let's work with the new coordinate. All right, so here, let's revisit the problem by looking at the new coordinate here. What is the equation? As earlier, we said the equation is this can be further simplified. All right, that's good. How about 9 equation here? Now, since 9 equation here does not pass in through the origin, now we're going to use a different form here for the straight line. Okay, so the standard form of straight line here, since it does not go through 0, 0, we can say the straight line is mx prime plus n y prime equal to 1. All right, so that's the equation in the new coordinate. All right, of course, the point P and Q satisfy both, right? Because that's the intersection of the straight line with the eclipse. So notice that in the current setup, P and Q, the x prime won't be 0, yeah, and also the line L won't be parallel to x-axis. So we have some observation here. M is non-zero because M0 would mean L is going to be parallel to x-axis. In this case, we assume that L is such that it has two distinct points with the eclipse, and also L does not pass in through A. Right? So another thing is that x prime in this case for P and Q, they're not equal to 0 because x is not going to be these 2 points here, right? So in that case, we can define y prime over x prime. In other words, slope is always well defined. We call it t here. T is the slope in the new coordinate, right? So this point P and Q satisfy both of the equation. Let's look at this equation here. We're going to do some transformation of the equation here. What we do is, so this is what we have, right? So what we want to do is for C, we want to divide x prime square on both sides, and we want to divide L equation here x prime. Now here you would imagine that if you divide x prime, this goes away. This becomes t square because t equal y prime over x prime. This becomes t, but then there is another term here, right? So this new equation, if we divide x prime square. Now for L, similarly, we're going to divide x prime on both sides because x prime is non-zero here. So this becomes t and x1 over x prime. Now 1 over x prime appear in both equations. Of course, P and Q satisfy both equations. So we're going to plug in the value into the equation C here, right? So what we get is we plug in, yeah. So this just m plus nt here is 1 over x prime. Now this is the equation in T, it's a quadratic equation. Let's rewrite it in quadratic forms here, right? So notice what's the meaning of this equation here. This equation says the point P and Q satisfy this, and T represents the slope of AP and AQ, right? So because in the new coordinate, the slope from point A, which is the origin, is always y prime over x prime. Alright, so this is all we need in order to prove the statement here. Okay, so what we have is that P and Q satisfy this quadratic equation, and also 9L go through 1, 1, this point 1, 1, but in the new coordinate is 1, 2 in the x prime, y prime plane. Alright, so here this should be dash, not minus. This means xy plane. Okay, sorry about the typo here. Now, if you plug in the equation, you would get this relationship. Alright, so what do we get here? Let's recap. So we know that T satisfies this quadratic equation in the meantime because L passing through 1, 2 in the new coordinate, so it has m equal this, or m equal 1 minus 2n. Now, from the quadratic equation, you know that two roots, t1, t2, satisfies the summation of t1 plus t2 is going to be 2m over 1 minus 2m. Alright, so two roots satisfy this equation here, but 1 minus 2n is nothing but m, right? So m cancels, that's equal to 2. In other words, we have proven that the slope AP and AQ add up to 2, right? Alright, that's the proof. Okay, so from this problem we know that sometimes math would be easier if you use a new coordinate. In this case, we translate the coordinate so that A becomes the origin of the new coordinate, and a lot of formula like a slope and other equations becomes easier, and then it helps us in making the math easier to derive. All right, hope you enjoyed the video, and please like, share, and subscribe.